we need to find the length of lattice rectum of an ellipse x square plus 3y square is equal to 12. Dividing with 12 on both the sides. So we can write x square divided by 12 plus y square divided by 4 is equal to 1. When comparing with x square by a square plus y square by b square is equal to 1, standard form of an ellipse, we can say a square value is 12 and b square value is 4. And the length of lattice rectum, which is perpendicular to the axis passing through the focus, we can say length of lattice rectum which is equal to 2 times b square divided by a, which is equal to 2 into b square value is 4 upon a square is 12, so a value can be taken as root 12. So we can write 2 into 4 divided by root 12, we can write it as 2 root 3. Four upon root 3 units is the length of lattice rectum, which is our option 3. Limit extends to 1, x to the power 4 minus root x divided by root x minus 1. Clearly we can say that when x is equal to 1, it is in the form 1 minus 1 divided by 1 minus 1, that is 0 by 0 form. So for 0 by 0 or infinity by infinity form, we can apply the L'Hospital rule. So we can differentiate the numerator and denominator repeatedly till we will not get 0 by 0 form. So let us apply one time. Apply L'Hospital rule. So differentiating the numerator as well differentiating the denominator separately. So we can write limit extends to 1. Differentiation of x power 4 is 4x power 3 and differentiation of root x is 1 by 2 root x. The whole divided by differentiation of root x is 1 by 2 root x and differentiation of constant 1 is 0. So we can simplify and write here limit extends to 1, 8 into x power 3 into root x minus 1 divided by 2 root x, the whole divided by 1 divided by 2 root x. So we may cancel the denominators and we can write limit extends to 1, 8 into x to the power of 3 root x minus 1, and here we can say that which is not in the form of 0 by 0 form. So we can simply substitute the x is equal to 1. So 8 into 1 cube into root of 1 minus 1, that is 8 minus 1, which is equal to 7. So we can say option 2 is the answer. Given a function y is equal to cos x upon 1 plus sin x. So let us differentiate with respect to 2x. So dy by dx is equal to, by applying u by v rule, u by v whole dash is equal to upon v square, v into u dash minus u into v dash. So we can write upon 1 plus sin x whole square. So 1 plus sin x into differentiation of cos x is minus sin x and minus u into that is cos x into differentiation of denominator is 1 plus sin x is cos x. So we can write dy by dx is equal to minus sin x minus sin square x and again minus cos square x divided by 1 plus sin x whole square. So here minus sin x minus, if I take common, sin square x plus cos square x, which is 1. We can write minus sin x minus 1 divided by 1 plus sin x whole square. Or you can take minus common, so you can write 1 plus sin x upon 1 plus sin x whole square. So upon simplification, we'll be getting dy by dx is equal to minus 1 upon 1 plus sin x. So which is our option 1. Option A is correct. And let us also simplify, which is equal to our dy by dx is equal to minus 1 divided by, and we know that 1 plus sin x is, we can write sin square x by 2 plus cos square x by 2, and sin x we can write it as 2 sin x by 2 cos x by 2. That is sin x by 2 plus cos x by 2 whole square. And let us multiply and divide with root 2 inside the brackets. So we can write dy by dx is equal to minus 1 upon root 2 whole square taken outside common. So we can write 1 by root 2 sin x by 2 plus 1 by root 2 cos x by 2 whole square, which implies dy by dx is equal to minus 1 divided by 2 times of 1 by root 2, we can write it as sin pi by 4, and here 1 by root 2 we can write cos pi by 4. So it is in the form of sin a sin b plus cos a cos b, which is cos pi by 4 minus x by 2, cos a minus b formula, which is equal to minus 1 by 2 cos square pi by 4 minus x by 2, which is minus 1 by 2 secant square of pi by 4 minus x by 2. So which is our option C. So we can say option C is also correct. So both A is correct, C is correct. So we can go with an option 3. A and C are correct. Let us consider the first one. Say f of x is equal to x into mod x. So we can write when x is positive, mod x can be taken as x, and when x is negative, mod x can be taken as minus x. So here we can write x into x, that is x square, whenever x is greater than or equals to 0, and x into mod x will be negative x square when x is less than 0. So mod x into mod x graph, we can say when x is positive, the graph will be x square, and when x is negative, the graph will be negative x square. So we can say this function is continuous in -1 to 1, and also this function is differentiable, that is f dash of x is equal to 2x when x is greater than or equals to 0, and negative 2x when x is less than 0. So f is also differentiable. In -1 to +1. If for x is greater than 0, 2x is positive and negative 2x is negative. So it is not neither increasing nor decreasing. So we cannot say it is strictly increasing. So this function is only differentiable. Now let's consider the second function b. Say g of x is equal to under root of mod of x. And as per the definition of mod x, we can write under root of positive x when x is greater than or equals to 0, under root of negative x when x is less than 0. So here we can see clearly the graph. For x is greater than or equals to 0, we can draw the graph. Root x graph will be this. The graph will be, it's a symmetric graph. So clearly we can say that this function is continuous. Continuous in the interval -1, 1. But this function g is not differentiable at x is equal to 0, because we have at x is equal to 0 there is a corner point where the differentiability is not defined. So that we can say this function, second function, is not differentiable at -1, 1. So not differentiable at x is equal to 0. At least 1 point, so we can go with an option 4. Now let's consider the third function. See, say h of x is equal to x plus square brackets of x, that is greatest integer function or step function. And we know that the greatest integer function, which is not continuous at integers, at all integers, because this function is a steps. So this graph is not continuous at all the integers, and hence it is not differentiable. Not differentiable at integers. But if you see in the interval other than integers, so x plus step x we can write for x lies between -1 and 0, step x value is equal to -1. So we can write x minus 1 and for x lies between 0 and 1, step x value is 0, so we can write x. So clearly we can see that the slope of these two are positive. Slope of x minus 1, that is h of x is equal to x minus 1, is 1, and slope of h of x is equal to x is also 1. So therefore we can say that h is increasing. H is increasing in both the intervals, that is we can say minus 1 to 1. So increasing function. So strictly increasing also we can say. So we can go with an option 3. Now let's consider the fourth one. Say p of x is equal to mod of x minus 1 plus mod of x plus 1. So let us consider in the three intervals. Mod of x minus 1 will be taken x minus 1 when x is greater than or equals to 1, or negative of x minus 1 when x is less than 1. Similarly, mod of x plus 1 can be considered to be x plus 1 when x is greater than or equals to minus 1, and x negative of x plus 1 when x is less than minus 1. So here we can write for the interval for x less than minus 1. So mod of x plus 1, mod of x minus 1 we can write it as negative of x minus 1 and negative of x plus 1. And for x lies between minus 1 and plus 1, so mod of x minus 1 we can write it as negative of x minus 1, and here we can write it as plus of x plus 1. And in the third case, when x is greater than 1, so we can consider both are like positive, that is x minus 1 plus of x plus 1. So we can also write the function. So negative x that is minus 2x, and plus 1 and minus 1 gets cancelled for the interval x is less than minus 1, and here negative x and positive x gets cancelled, and plus 1 that is 2, it's a constant for x lies between minus 1 and plus 1, and for x is greater than 1 we can write here 2x where x is greater than 1. Clearly at x is equal to minus 1, at x is equal to minus 1, your left hand limit extends to minus 1 minus f of x, which is equal to minus 2 into minus 1, which is equal to 2, and limit extends to minus 1 plus f of x, which is equal to 2. Both are same, and even at f of negative 1 also is considered to be 2. As for minus 1 to plus 1. Minus 1 to plus 1. When minus 1 is included here. Or here 1 is included. So we can say this function is continuous at x is equal to minus 1. And even at x is equal to 0. At x is equal to 0, the function is continuous. F of 0 is equal to 2. And even at x is greater than 1, at x is equal to plus 1 also, we are getting that function is continuous. So clearly f is continuous on interval minus 1 to 1. But it is not differentiable because here you are getting the left derivative is minus 2 and right derivative is 0. And greater than 1, the derivative is 2. So they are not equal and hence we can say not differentiable. And they are neither increasing nor decreasing. So we can go with an option only continuous in minus 1 to plus 1. Fourth D is first option. So finally we can give the answer A second, B fourth, third 3 and D 1, which is option 3. Given the function f of x is equal to e to the power of x plus ax when x is less than 0 and b times of x minus 1 whole square when x is greater than or equals to 0. Since this function f is differentiable, we can also say that f is continuous at x is equal to 0. So let us consider the left hand limit. Limit extends to 0 minus f of x, which is equal to limit extends to 0. Below 0 we can consider the function e power x plus ax, which is equal to e power 0 plus a into 0, which is e power 0, which is 1. And right hand limit extends to 0 plus f of x, which is equal to limit extends to 0. Above 0 we can consider the function as b times of x minus 1 whole square, that is b times of 0 minus 1 whole square, so which is b. Since the function is continuous, so we can say left hand limit is equal to right hand limit, so b is equal to 1. And now since the function is differentiable, f is differentiable, so let us consider the left hand derivative. Left hand derivative at x is equal to 0, which implies that is d by dx of e to the power of x plus ax, which is equal to e power x plus a. At x is equal to 0, we can write e power 0 plus a, which is 1 plus a. Similarly, the right hand derivative at x is equal to 0, we can write d by dx of b times of x minus 1 whole square, that is 2 times of b times x minus 1 into differentiation of x minus 1 is 1. At x is equal to 0, we can write 2b into 0 minus 1, which is minus 2b. And we got the value of b is 1, so which is minus 2. Since the function is differentiable, so we can write left hand derivative is equal to right hand derivative, that is 1 plus a is equal to minus 2, so a is equal to minus 2 minus 1, so a value is minus 3. So the value of a is minus 3 and value of b is 1, which is our option 3. Option 3 is the answer. To check the continuity of this function, let us consider left hand limit at x is equal to 0. Limit extends to 0 minus f of x, we can write limit h tends to 0, f of 0 minus h, which is equal to e to the power of 1 upon negative h minus 1 divided by e to the power of 1 upon negative h plus 1. So we can also write this as 1 upon e to the power of 1 by h minus 1 divided by 1 upon e to the power of 1 by h plus 1, where the limit h tends to 0. And we know that as h tends to 0, 1 upon h tends towards infinity, and e power 1 upon h tends to infinity, and 1 upon e to the power of 1 by h tends to 0. So we can write here 0 minus 1 divided by 0 plus 1, which is negative 1. So left hand limit we got it minus 1, and coming to the right hand limit, limit h tends to 0 plus f of x, which is equal to limit h tends to 0, f of 0 plus h, which is equal to limit h tends to 0, e to the power of 1 upon h minus 1 divided by e to the power of 1 upon h plus 1. So here let us simplify by taking e power 1 by h common. So we can write 1 minus 1 upon e to the power of 1 by h divided by e to the power of 1 upon h common 1 plus 1 by e to the power of 1 by h. So that we can cancel e power 1 by h numerator and denominator, and we can write it as limit h tends to 0, 1 minus, as e power 1 upon e power 1 minus h, 1 by h we can say 0. Similarly, 1 upon e power 1 by h will be 0. So which is equal to 1. So here left hand limit is minus 1 and right hand limit is plus 1. So both are not equal. And hence we can say the function is not continuous at x is equal to 0. Option B. And hence it is not differentiable. So given the equations, y is equal to a sine power 3 t and x is equal to a cos power 3 t. So both x and y are connected with the parameter t. So let's differentiate with respect to t both the equations. So we get dy by dt is equal to a into differentiation of sine cube is 3 sine square t into differentiation of sine is cos t. And here dx by dt is equal to a times 3 cos square t into differentiation of cos t is minus sin t. So here we can write 3a sin square t cos t, and here minus 3a sin t into cos square t. Now let us consider dy by dx. So we can write it as dy by dt divided by dx by dt, which is equal to 3a sin square t into cos t upon minus 3a sin t into cos square t. So we may cancel here the terms. So which is equal to minus sin t upon cos t, that is negative tan t. We got dy by dx is equal to dy by dx is equal to minus tan t, but we need the question dy by dx at t is equal to 3 pi by 4. So dy by dx at t is equal to 3 pi by 4, which is equal to minus tan of 3 pi by 4, that is minus tan pi minus pi by 4. Tan pi minus theta is second quadrant negative, so negative minus of minus will become plus tan pi by 4, which is equal to 1. So we can write here, since tan pi minus theta is equal to minus tan theta. So the answer is 1, which is our option 4. We need to find the derivative of sin x with respect to log x. So we know the differentiate y with respect to x, or we can say differentiate f of x with respect to g of x can be taken as d of f of x by d of g of x, and which can also be written as d by dx of f of x divided by d by dx of g of x. So here we consider, here f of x is equal to sin x and g of x is equal to log x. So the derivative of sin x with respect to log x, we can write it as d by dx of sin x divided by d by dx of log x, which is equal to differentiation of sin x is cos x and differentiation of log x is 1 upon x, which is x cos x. X cos x is the answer, which is our option 2. We need to find the minimum value of 1 minus sin x. So let us consider, let f of x is equal to 1 minus sin x, and we know that the range of sin x is minus 1 to plus 1, and negative sin x also lies between minus 1 to plus 1. Then adding 1, so 1 minus 1 less than or equals to 1 minus sin x is less than or equals to 1 plus 1. So 0 less than or equals to 1 minus sin x is less than or equals to 2. That is 1 minus sin x is f of x. F of x value lies between 0 and 2, where 0 is included. So we can say this is the minimum value and 2 is the maximum value. So we can say the minimum value of 1 minus sin x is equal to 0. So which is our option 1. Given the function f of x is equal to tan x minus x. So to verify whether it is increasing or decreasing, let us differentiate. Differentiate with respect to x. So we can write f dash of x is equal to differentiation of tan x is secant square x minus 1, and secant square x minus 1 is tan square x. So for any value of x, means for all x belongs to r minus odd multiples of pi by 2, because this is the domain of the tan. So we can say tan square x is always greater than or equals to 0. So therefore we can say that f dash of x is greater than or equals to 0, which indicates that it is always, therefore f is always increases. So we can go with an option 1, always increases.